Welcome to the Harvard Data Science Initiative's Industry Seminar Series. I'm David Parks, and along with Francesca Dominici, I'm one of the co-faculty chairs of the initiative. And today, I'm very excited, we welcome Rohan Murty and George Nychis from Soroco, which is building systems and algorithms that analyze billions of data points on human interactions with software systems to understand how we work. This is giving us a fascinating and unprecedented view into the way that we work every day with software systems. I know that Soroco's technology is already being deployed at Fortune 500 companies worldwide and used to uncover new and unique insights in the field of task and process mining. I also wanted to mention that, as far as I understand it, it's already led to 2 Harvard Business School HBR articles. A little bit about the co-founders. So Rohan Murty is founder and CTO of Soroco. I know Rohan from his time as a PhD student in computer science at Harvard, when I had the chance to serve on his committee, as well as collaborate with him on the economics of sharing wireless spectrum. He's also been one of the very few computer scientists who was a junior fellow of the Harvard Society of Fellows. So I wanted to mention that going beyond his technical expertise, I know from conversations that Rohan cares deeply about education and has written about the importance of a culture of education that fosters a deep respect for curiosity, learning, and diverse views. He also has a passion for literature and is the founder of Harvard's Murty Classical Library of India. His co-founder, George Nychis, and VP of Architecture at Soroco, received his PhD from CMU and has published research that has spanned the areas of distributed systems, security, and network communication. When I mentioned to all of you in the audience that there will be a chance for Q&A, which I will lead at the end of our hour together, and feel free to use the Q&A tool as we go through the talk. With that, welcome Rohan and George. Please take it away.
Great. Thank you, David. Thank you very much, David, Kevin, and Jennifer. And thank you, everybody, for attending. I also think there are a couple of folks from India who dialed in at maybe 1 in the morning or 2 in the morning. So thanks for staying up. All right, so let's get going. George and I are incredibly excited to share the vision of what we do, what we work on. And this is, to be clear, this is not a talk about a product. This is rather a talk about what we believe is a very exciting area of data science that we have stumbled across as part of our work. And we have managed to find some very interesting insights we'll share with you. And to get going, what we'll do is I'll just give you a sense of an overview, and then George will take us through some details. In the end, George and I will take you through some of the findings. George, since you control the slides, let's go to the first one. All right, so it says in the title, Workgraph and so on. So what is the Workgraph? So imagine for a moment if you're drawing a map, and the map is meant to show how your teams get digital work done. Or today when we all go to work, we use lots of different applications for doing all kinds of different tasks. And so you have ERPs and CRMs, and these are like the big beasts, the big landscapes, landmarks in the landscape. You have web-based applications and different IT applications. These are probably the smaller buildings, of which there are many. And you have lots of different streets and roads. These are variations. And then you have people who are, the millions of cars moving through the city, and documents are the delivery packages. I highlight these entities because these are commonly what we see when people actually do work using technology anywhere. And so now, if you examine the state of the art as to what has been possible thus far, what you'll notice is, George, just a click, please. Just one more click, George. Okay, you'll see a map that actually has some of these big landmarks. It may show you a few streets here and there, but the fact of the matter is you can't really see most buildings. Most buildings are grayed out or totally absent. They're not even there. There's not even visibility to see most of these buildings. You often don't see many roads. These roads are not really well connected to each other. You don't see all cars. And you certainly can't see any of the delivery packages or the documents inside cars. And in some sense, this has been the state of the art in the industry, which is companies have been doing one of two things, actually maybe one of three. One is they have been examining log files of ERP applications and some of these big applications and saying, hey, I'm going to help you figure out what's going on at work by looking at these application log files. You can improve things. But as soon as you get to enterprise, you very quickly realize most applications don't produce a log file, or at least don't produce a log file with high fidelity, and certainly don't produce a log file with a common format. So that approach doesn't really capture most of what's happening. And the second approach that people have been following is to use workflow software, like you can use Asana or many other companies that tell you, hey, use my piece of software and I will restructure how you work, and so on. But what we've been interested, and the third approach is people hire consultants. Consultants will come, let's say you're a company of 10,000 people, they'll interview maybe 10, 20, 30 people, they'll produce a high-level sketch of what's going on, and then they'll give you advice. But all of it looks like the map on the right-hand side, which isn't much. Whereas what we really want to be able to do, George, one click, please, is something like this, right? This is the kind of a map that we're used to, and this is the kind of map that really helps you figure out how do you get from two different points, where are there log jams, where are there sources of friction, and so on and so forth. So what we at Soroco have been doing is we've been building a platform that we call Scout. And Scout is this incredibly scalable platform that generates essentially a map of your digital landscape of how work is happening. And we call this as the Workgraph. Later on, we'll show you a sample of the Workgraph and how you use it and so on, but I at least just wanted to set the context. Go to the next slide, George. All right, but building the Workgraph is hard. And how do we build this Workgraph? Well, it starts from this insight that as opposed to relying on log files or interviews and so on, we find that about 75% of all interactions that take place at work, it's an estimation, are all undocumented interactions. And what I mean by that is interactions with software on your machine. I entered an address in this field, I clicked on the submit button, I uploaded a document, I downloaded something else, I pulled information from 5 different systems, and I put information to 20 different systems and so on. And because they're, by definition, because they're undocumented, you don't really have a good idea of what's going on. So really the biggest mystery in understanding work happens in the last mile, that is the human-machine interface at work. And that is what we tap into. To put it one way, we essentially capture interactions between people and machines, anonymize the data, because we don't want to know who did what, aggregate it to a team level, to the level of a team, and then find patterns in this data that will tell us how is this team getting work done. Now, it turns out this data is incredibly rich. And just to sort of place it in context, people are very impressed with the kind of interaction data on Facebook, and justifiably so at an incredible scale. But it turns out the average user on Facebook, as per information we can find on the web, does about 5 interactions each day, a like, a comment, and so on. Whereas it turns out the icon on the right-hand side is a Workgraph icon. The average user, perhaps many of us on this call, when we go to work every day, we're doing 2,800 interactions on our system. I sent an email, or I entered an email address, or like edited a document and whatever else and so on. So just in terms of sheer density of data on a per user basis, we have incredibly large digital footprints that we're creating every day. In fact, on this very call, we are creating a larger and larger digital footprint of data that can be used potentially for helping figure out how to improve work. And so that's why there is a ton of data that's being generated every day at work that we thus far have been throwing away from these interactions. And our whole approach is to capture that data, to clean it, to make sense of it, and ultimately to help companies improve. And so effectively what we do is capture all of this undocumented data and create a structured view of how work happens. And that's what our platform Scout does. Everything we show you today will be based on insights that our platform has gathered and so on. All right, George, over to you.
Perfect. Thanks, Rohan. So now that Rohan sort of set the context around a little bit of the work graph and why we're studying it, I just want to present an overall outline for the remainder of the talk today. First, really looking forward to sharing a lot of unique insights with all of you throughout the talk. We'll start out by presenting why it's so difficult to understand how teams work, where current approaches leave a lot of the gaps that Rohan talked about, and ultimately the difficulty of that motivating us to build the work graph of information, which is this very granular set of data that allows us to obtain a complete view of work as it's done. And with that granular data in the graph, we're going to present some really impactful findings, such as, for example, how variable the steps followed can be between two employees simply trying to do the same work. And without data to uncover that, any transformation initiative would have failed. And at the end of the talk, we'll leave you with some future initiatives that we believe can be impactful on the work graph. So let's just go ahead and begin by building this joint understanding of why it's so difficult to understand how teams work. Okay, so just imagine the following. Okay, you're a manager of 10 people. You have this great responsibility to ensure your team is productive, that they're having a good experience, the processes that they follow are efficient, and you probably have several company-led initiatives to transform several of these processes to be more scalable, more efficient, and have an impact to the business. Now, while you have this great responsibility, you're also a little bit in the dark, right? You talk to members of your team throughout the week, you hear a lot of things about their workday, but you don't have data to more deeply understand what you're hearing and understand their work. Conversations can't accurately convey the detail behind the fact, like Rohan said, employees are taking 2,800 actions on their machine every day, let alone your team of 10 people who are taking 28,000 actions a day happening across that team. You really don't know what work is being done. What applications are those teams using, like those landmarks Rohan was talking about? Have they created new, quote, packages like Excel documents that they're driving around that you aren't aware of? And if all these 10 members of the team are doing the same process, are they even doing it the same way at all? I've had a personal experience where an employee didn't know there was a bulk upload functionality that existed. How were they supposed to know? How was I supposed to know? This is why understanding a team's day is hard and the work is hard. And conversations, like Rohan rightfully pointed out, are not sufficient enough. It's point in time, and they create these inaccurate views of work. So let's go a little bit deeper into what Rohan mentioned earlier. Is there's been some prior work around trying to use information like log files to try to gain an understanding. Up here on the screen, I have something like 3 users, and what they're doing is they're accessing various applications throughout their day. Now, what prior work has done is try to analyze things like server-side application logs to kind of find these little breadcrumb trails of teams' work throughout the day to understand it. So what I mean by that might be, let's say Nancy is working on invoices and uses an internal application to complete invoices. So what might happen is when Nancy completes the invoice, there might be a little indicator in the log that said, Nancy completed the invoice at 1 p.m. today. And if you analyze all the application and system logs, you might be able to find these little breadcrumbs. But what's missing from all of this, though, is what did really the employee have to do to complete that work? We all know that they completed an invoice, but how much time did it take them to do it? Did they need to pull up other information to actually complete it? Did they run into an exception that led them to take more time? Did they need to reach out to other team members or other departments because of an issue that came up? None of this will be possible to know by purely looking at system application logs. And what that means is you as a manager won't deeply understand that employee's experience or their day. Our analysis has shown that at most, you might be able to understand 25% of that individual's day, but you're really missing 75% of the effort that really goes into the team. And you'll see this again later on as Rohan walks you through a really important finding about what we call the work recall gap with the manager. So this is what motivated us to build the work graph, which is based on observing these users' 2,800 interactions with business applications throughout the day. For every interaction taken with the applications, we start to get very rich metadata that occurs with it. We see exactly what they interacted with in the application, the information that's available, and all of this will be really critical to closing that gap in understanding the user's day. So let's just see what that looks like. So Rohan shows you that kind of map. Let's see what this looks like for the actual individual and completing their work. So what we're talking about is being able to capture these paths, sort of like every nook and cranny of the individual actions that took place for them to create work in the environment. This is like an X-ray of the team's work. We're not talking about time and motion studies, such as how much time was spent in Excel. What we're really talking about are things like when you got an email from a customer, how likely are you to put that email into a CRM system versus not just go directly to the order portal? This graph is all about creating the detailed sequences of the work. And it's a directed graph. That's important to basically understand the probability that certain actions take place in the actual work being done. And so this helps us understand the likelihood of certain actions or steps that might occur based on prior actions. And this is critical. This level of detail in the sequences that are shown is critical to understanding the work. But now, what can you do with this information? So imagine that there's a KPI that exists that you're trying to improve upon, such as creating additional effort or capacity within the team. So you're trying to minimize manual effort that occurs. And so what you can do is you're going to start looking at this graph and saying, look, okay, first I see a lot of users doing various steps. So that looks like a great opportunity for better training. If we can more efficiently do the process through training, we can reduce that manual effort. Then you start seeing that there's a lot of effort in something like, look, we're going through responding to various emails, but there's no standardization around it. Maybe you need to invest in standardization to reduce that manual effort there as well. You'll start finding opportunities for things like IT enhancements. So you notice that there's a lot of time spent in various applications that we think can actually be made more efficient. You might begin to do things like templatize certain steps. And what we'll talk about later also is, finally, you can even automate some of them. But without these detailed sequences at this level of granularity, you would not know how to accurately make these kinds of transformations internally. And so this is really what the work graph is bringing to the organization through this level of detail and the steps. Okay, so what we've shown you so far is the power and potential of this work graph. Given the audience that we have, we want to go a little bit deeper with you to actually show you what that work graph looks like. So, Rohan showed you a high level of, sort of like a map and a streets, but let's actually see what the work graph looks like in structure within the enterprise. So within the work graph, like any other graph, we have key entities that are important. These entities have the various things like Rohan mentioned earlier. It is the team members, it is the construction of the teams, it's all the documents that they access, it's the various steps that they take. Like all graphs too, there are relationships that are placed into it. And these relationships basically draw the important information, such as when the user was conducting this step, they were accessing this particular document. And that same relationship might exist from another user, starting to build a powerful understanding of what users are accessing various information and drawing these detailed maps that exist in the organization. So this starts to help you understand a little bit more about what the work graph actually looks like in the enterprise. Creating this work graph is non-trivial, especially the top left-hand side that we're showing around things like processes and tasks. So it's very, straightforward to maybe add steps to this work graph, but a key thing that we provide through it is annotating the graph with higher level insights of entities and relationships such that we can ask more meaningful questions. This graph has to be annotated with what exact work was being done by the end users. And so what we have are techniques to take these 2,800 actions across the day, like Rohan mentioned, and to be able to annotate it to a specific process. Now, this is critical and key to the work graph that allows us to be able to query it to say something like, give me 100 instances of Nancy doing the invoice process. Give me 100 instances of Bob doing that same process. Now let's compare them together. And this is what allows us to basically bring out more insightful information from this graph. And as many of you being data scientists into this room, what I just thought I would do is spend probably 2 more minutes, and then we're going to get to some of the findings that we actually can pull out from this graph. So finding the patterns in this graph and uncovering these hidden patterns, we have a number of different techniques. We could almost spend an entire talk on this alone. But I think it's important to understand how we take these 2,800 actions and relate them to processes that the teams conduct. So how this works within the teams and how all the insights you'll see later on is generated is we take a small set of samples from the teams that are effectively like little pieces of training that are given to our classifier for it to understand what the processes look like. And so what we do is we have teams train our models to discover the hidden patterns by only having a few members of each team provide examples of the process. So for example, if you had a team of 10, we might ask 3 of them to show examples of the process 3 times. That trains the classifier, which then allows us to attribute the steps to particular processes. And so there's a lot of depth into how this works. I would actually encourage people to read our blog, engineering.soroco.com, where we actually explain some of these more techniques in depth and how important things like vectorization is in the data to make sure that even if 2 employees do it in a different way, that we can still find these patterns. And so what this would look like under the hood, just for a second, because I know many of you are technical and data scientists on the call, is if you imagine the user's interactions across the day from left to right, what you would find is that the ML classifier peaks when it believes strongly that a user is doing a particular process. And that can even be independent of things like variations in how they do it. So you'll find that it peaks to say, I'm confident based on the user's training that I believe that they're doing the process at this point. So that just sets a little bit of context behind, all of the work that we've done to build the work graph. And I think now we want to actually take you through some of the, the really insightful findings that we've had from it, by which I'll pass it back over to Rohan.
Great. Next slide, George. Some very basic stats to give you a sense, how big does this graph get, right? So on the left-hand side, if you take a single team that we have seen in our data sets thus far, the average team size is about 11 people. And these 11 people every day execute about 23,000 steps between themselves. Each person accesses a document about 36 times a day. And context switches, that is, hits Alt Tab and moves between different applications, roughly about 1,000 times a day, each user. And some of these results will become relevant through our findings later on. And each user also accesses about 7,400 non-unique data fields in a day. And when we blow this up and we start looking at this at the scale of a typical Fortune 500 company, roughly about 60,000 users in it, there are about 31 billion on an annual basis. There are 31 billion steps or nodes in this graph. This is just for one company, right? Now, imagine you take this one company and you blow it up by, a few thousands of companies and so on. You can imagine the scale of the data that we're talking about. And there are roughly about 500 million document accesses that happen in one company in the year, about 15 billion context switches, and 111 billion data field accesses. So there's just incredible amounts of data that we're all generating at work every day. I think that's really just, I wanted people just to take that away. All right, George, let's go to the next one. So the first, there are lots of questions and interesting answers we have found. We are going to focus on five for the purpose of this talk. The first one is some joint work that we published in HBR in December with folks at Harvard Business School as well as at Wharton. So the question we asked was, So how much do managers understand how their teams are getting work done today? And the reason this question is important is you first need to have a reasonable sense of what is your current baseline. How are your teams spending effort? How do they do the same kind of work and so on before you invest in changing any of that, right? And these days there are these buzzwords saying digital transformation and so on. Well, you can't really transform or change something if you don't really know the ground truth. So how much of ground truth do managers understand today? So we have some data and a setup where it was about 14 different teams in 4 different Fortune 500 companies and about 283 people. What you see, George, we'll just hit the next key, please. Yeah. So we first asked managers, how much of your team's daily efforts do you think you can account for? And we did a survey, an informal survey, and the broad answer that we got was, I think I can reason for about 80% of my team's daily work. And so we said, okay, so that should be the common expectation. No manager will tell you that they can reason for 100%. That's hard. So we said, okay, so 80% is the bar. Now, how much do they actually know in practice? George, if you can hit a key, please. All right. So what we found, though, was on average, managers knew roughly, I think it was about 23-ish% or so of their team's daily work. And the way that we were able to measure this was we gave our managers, George earlier on talked about the supervised learning part of things. We gave them a tool whereby they could teach a few samples of, how they thought their teams were doing work. And then we have, a network that learns these patterns and then goes out into the wild and attempts to match against other patterns in the graph versus, to what the manager taught. And there is some degree of tolerance, obviously. And the more we find, the more the manager knows. The less we find, the less the manager is able to account for. And so what you see in the graphic on the right-hand side is we set 80% as a common bar. And the green is the extent to which across these 14 teams, the manager could reason for. And you can see in some teams, it's as much as 42%. In some other teams, it's as low as 4%. And there are different reasons as to why this happens. George, you can hit a key, please. And then one more key, George. And we found that, a predominant reason why managers often can't account for how much they think they ought to, is because the work that's happening in their teams is happening in too many different ways. So, the manager may only know of 1 or 2 or a few ways, whereas the teams are probably doing it in several other ways. Or sometimes the teams are doing things that the manager did not even anticipate. So we then came up with this term that we call as the work recall gap, which we define as what the manager expects minus how much they are able to account for. And our finding is roughly the gap is quite wide, as you can see. In fact, I'd encourage you to come read our article that talks a little bit more about why this gap exists and how we measured it. So the next question that we asked was, okay, given that this is quite stunning for us. This is quite a serious gap. How can you help managers? This is not, to be sure, right? This is not to blame managers. This is all done in a post-COVID world. Everyone's working remote. There are no hallways where you can walk down the hallway and figure out what's going on. This, if at all anything, this just makes the case for why managers need help, how you can equip them. And they're trying really hard as well. They're trying their best, but they need some additional help, and maybe technology can help. So how do we use this work graph to help? So George, let's go to the next slide. All right, so what we basically did was we applied a series of, again, learning-based algorithms that were able to find more patterns in the gap that we had found. We were able to find patterns that were recurring and repeating. And therefore, we were over time able to, we take what the manager's intuition is, plus what the learning algorithms find. When we put them together, we can dramatically reduce the gap. And you kind of see the left-hand side and the right-hand side, the yellow bits dramatically shrinking. Now, we can't eliminate the gaps, or at least we haven't yet figured out how to eliminate the gaps, even as per the manager's expectation, but we can certainly shrink the gap. So this is an example of how using machine learning applied to the work graph can help reduce the gap in a manager's understanding of the baseline of how work happens in their teams. This was our first finding. George, we'll go to the next slide.
Yeah.
This is for you.
Absolutely. So like Rohan said, one of the big potential reasons for this gap is variation in how the work is done, and not understanding all the different exception scenarios that can come up and so on. And so what we want to do is actually show just how variable is this work exactly. And just so we align on the same terminology, when we say the word variation, we mean a different set of steps when users conduct the same work. And this is where a bunch of really important techniques come up from things like graph isomorphism to be able to find variance across processes and how the users conduct the work. There's one really important primitive here, which is being able to compute the similarity between two sequences. It's like taking two users' work and saying how much of it is similar and how much is different. And understanding variations is critical. If you want to go through any transformation of going from as is to be, you need to know as is. And we'll show you just how big of a difference there is in as is processes. We want to deep dive in variations just by aligning two more pieces of terminology with you: minor variation and major variation. So on this slide, what we're showing are minor variations. We have the process sequences like we showed before, and we have colored differences between the process sequences. Minor variations are things like 25% of the steps or less being different. And so if you imagine 10 steps, then you would say a minor variation is less than 3 steps in difference in some way. A major variation could be something like the following. On the right-hand side, we've seen a major variation occur where 3 steps or greater are now different in how the users are doing the process. This could be for various reasons, like Rohan mentioned. It could be an exception that occurs. It could be different steps needed to be able to handle certain types of input provided. But these are 2 key terms that we just wanted to make sure that we're aligned on. Now let's just actually show some of the study that we went through together. Let's just see how much variance there is across team members executing the same work. So we studied 120 different people across 12 teams, 88 processes in one organization. Just as some high-level statistics first about the variations we observed, 20% of these processes had 2 variations or less. These are probably highly conformant in some way, or the users are very trained on them. And then 10% of processes had 8 variations or more. Think of that, 8 different paths to go between the points together. That really makes it difficult to understand work on the ground. And as one more impactful process level finding, 65% of processes have at least one variation that only one user conducts. This is why interviewing point individuals will never work, right? And this in particular is either a great opportunity where they're executing an optimized path, or it's a great risk that only one user is conducting this particular path or knows how to handle these exceptions. There are even deeper findings that we think have great significance in variations. If we go a little bit deeper into that classification of major and minor, 86% of all variations we found are major. That means a significant number of paths exist that are extremely different in how users do the same work. And not only that, but even more challenging to the problem, there's a lot of them. On average, each process has 5 variations, meaning if 86% of variations are major, 4 out of those 5 are major variations across your processes. The implications of this in particular combined is that when a company decides that they want to improve work, it's significantly more complex than just trying to optimize one path, right? And you're trying to optimize some n by 5 on average, and 4 of those 5 are highly variable. And finally, only 53% of variations are conducted by all members of the team. That has a huge implication itself, right? And this is why it's important to capture the entire team's work, right? And this is why interviews won't work at scale again. To understand processes, you have to understand every individual on the team. And so some key takeaways here are establishing a baseline for work is hard. It needs technology, It needs to cover the entire team. And any transformation effort is likely to fail without data to guide it. The third finding that we want to take you through really quickly, why don't you go ahead on the automation findings, Rohan?
Sure. One of the things that we saw was consulting companies write reports saying, automate, this is how much the workforce can be automated. Or we saw the World Bank put out stuff and various institutions at different points in time. And the thing that we as computer scientists never understood was, hey, how do these guys come up with these estimates? And the more we dug in, the less it made sense to us, at least. We are like, wait, we are actually talking to people doing work all day long in different companies, in different industries. None of those estimations really seem to map here. On the other hand, we have this really rich graph that has every granular step of every interaction. So what we realized is we could actually build up an estimation of how automatable work can be, at least digital work, ground up instead of a top-down approach, or instead of a broad brush stroke approach. So we actually took data from the following kind of setup, about 300 odd people, 37 different teams doing all kinds of different work, supply chain, HR, finance, et cetera, and so on, 10 different companies. And then we have an algorithm and a heuristic for estimating how automatable is a certain sequence or a flow in the graph. It is based on a variety of factors, including how many variations, or the nature of the work, how repeatable is it, do we find it often, and so on and so forth. And there were no interviews. This is entirely with technology, right? And so we estimate that roughly about 1/3, George, I think you can hit the key, 1/3 of the manual effort that we have seen in our customers built ground up is actually automatable. That's our estimation. And at least as far as we know, this is the first such estimation being built ground up versus our top-down broad brush strokes approach. This too we are able to find on our graph. The next slide, George. All right, so then in a different scenario, we ran into this very interesting case. I'm going to first tell you about the specific case, and then I'll step back and tell you the broader result. I have my colleague Rajat who's on this call. So Rajat and I and my colleague Arjun were looking at data where this was just around the start of the pandemic. And in this, we found a particular setup where, in the y-axis is on a per hour basis, how often did a team member get online? And we found this data on our graph. And on the x-axis is what fraction of that team were online together at the same time. And unsurprising, and all the numbers that you see are a number of units of work that the team actually processed. Unsurprisingly, as you come, as the y-axis increases, as you're more available, you get more done. No surprises there. But then the team overlap turns out to be a very interesting dimension, which is as the team's members begin to overlap more and more, we actually begin to see more and more units of work being produced. Because the nature of this work was such that they required some coordination, some cooperation between different team members, and therefore they were able to produce more. But then we started to find this very interesting pattern where beyond a certain point, excess overlap meant that team members started spending more time in meetings and the overhead of coordination was higher, and therefore the numbers started to drop. So there was actually a sweet spot, and we started to notice this pattern in a couple of different scenarios. And beyond this sweet spot of overlap and being available, particularly in a remote work from home situation, actually doesn't help. And so then we decided, okay, let's go study this across a larger set. George, the next slide, please. The next one. Right. And we published an HBR article with my friend Scott Commoners, who's faculty at HBS. And what we found was, we said, okay, when does team overlap really matter? Because, in the previous example, in that particular team, the peak to trough difference was 2.4x. So forget any kind of investments into automation or whatever else and so on. If the manager just controls for certain patterns of work, the overlap, that makes a difference. Of course, this matters when you pretty much have coordinated work. So we started to measure this across several different teams doing different kinds of work. And then we started to find in certain teams, certainly when you're doing solo work, this doesn't really help, or it doesn't matter. But the surprising thing that we have found, and I must admit, we don't understand it to the fullest extent as to why. We're still trying to study as to why exactly this happens. In some cases, we find overlap actually hurts. And our working hypothesis is that overlap leads to more interrupt-driven work in meetings and distractions and so on. But is there something more to it than that? That's something that's yet to be resolved. And the reason why this becomes really important is this is a very easy lever to provide team members and managers when they all want to work together and want to be effective, without having to go kind of interstellar into automation or anything else and so on. So this was another result that we found very interesting. George, the next slide, please. This is the last one, but this is preliminary. So it's still ongoing. But the reason I decided to put it up for today's talk is I find this absolutely fascinating and shocking. We have actually seen, if you think about it, right, in life and in any kind of thing, there is a cost to context switching, right? You lose efficiency when you context switch. So we asked ourselves, what is the cost of context switching in the context of digital labor? We have seen scenarios where people would have to context switch on average for a single transaction 300 times. Can you imagine if you're doing a piece of work all day long, where all that you're doing is you're hitting Alt Tab, pulling data from a system and sticking it to another system? That's your function, right? And the biggest champions for us in these scenarios were the people doing this work. They're like, wait, I really hate what I'm doing. Like, this is just not fun. And so what is the cost of that, right? And so what we did was we found a set of transactions, all of which took similar time. And then we just plotted how many of these, what was the throughput for these transactions versus how many context switches do you do? So we actually think there's perhaps a more interesting psychology and computer science intersection research to be done based on this data, which is the micro costs of context switching, of hitting Alt Tab and moving between different applications. And what we have found, this is preliminary, is that roughly every n times that you context switch, maybe that n currently is 30, maybe it'll shift, you actually lose productivity. And this is actually happening because, and it's not anybody's fault except, the way companies grow is, I have a need today, so I design a system and I put some data into it. And tomorrow I have another need, so I build another system. Oh, these two systems don't talk to each other. So what I end up doing is, I'm just going to have a person be the glue between these two systems. Oh, I'm just going to scale this team because I have more pressures and I have to do more. But guess what? The more you do this kind of stuff, it actually hurts. It slows you down. And as far as I know, this is the first time that we're able to find actually in the literature the costs of context switching and here context switching really means, context switching between applications in the software world. And what does it do to a team's productivity? And so these are some of the interesting findings that we found. And George, do you want to close it up?
Yeah, thanks, Rohan, and thanks, everyone. There's a lot more to the Workgraph that can be studied on it. We don't want to point out any particular questions. We actually have a lot of questions in the Q&A already of, could you basically infer this from the Workgraph? But there's a lot of major themes that need additional focus. How do we improve the employee's experience at work? How do we provide better ongoing mentorship and training opportunities based on knowing their experience? What better technology investments can be made? What are the right team structures and geographical layouts? And we're all trying to continually improve some customer satisfaction in some way. So many more topics to go through, but really appreciate everyone's time. Thanks so much. And passing it over to David now.
Thank you. Thank you so much, Rohan and George. I feel that we're getting just a new, unique look into work. And I'm sure there are lots of analogies here, but the microscope obviously advanced our science a lot. And it seems like you're really showing us new things. I wanted to say just procedurally that I saw a couple of people raise their hands. If you have questions, you can just go ahead and type in the Q&A. I wanted just to start, before we get to some of the public questions, one thing I just wondered if you could comment really briefly on is, where are the big technical challenges here? I mean, you talked about the scale, Rohan, and you compared the scale, the number of actions here to number of actions on on Facebook and things like that. You're both systems guys. What was hard? I mean, I'm sure a lot of this was hard. Just share a little bit of that with us.
George, you want to go or should I go?
Yeah, we could both take a minute on it. There are so many technical challenges that we've sort of made look easy in this talk. Alone, collecting those 2,800 actions a day is not easy to get accurate across such a heterogeneous set of applications in the enterprise. We've done a lot of things that we filed patents on to make that easy to support new applications along the way, and that's one. And actually discovering what steps belong to what process, these machine learning classifiers that I briefly glanced over in a slide have really taken a tremendous amount of work internally with various PhDs, our colleague Michael and some of the team, and my colleague Wolf and the data agent team collecting it. So this has been a really major technology effort.
So David, some of the challenges are, so for example, data capture, right? We capture data, the way that we are choosing to solve this problem is we don't require any integration with any application. So in real time, we have to capture, so when you do a click or whatever, when you do an interaction, within 30 milliseconds, we have to capture all the context. And by talking to the operating system. I mean, there are some systems challenges. I just want to give a flavor of that. So there are a whole set of systems challenges there. And then, of course, before we write anything to disk, we anonymize data because we want to protect the privacy of the end user. And we don't want to write the user's ID or anything to disk, or even at the moment we write it, it can cause all kinds of issues. So then, when you start going towards those kinds of problems, there are a set of problems we had to solve that. And then when we start aggregating the data, we have an incredible amount of noise. And it's sort of like, the analogy is, you have a trillion-piece jigsaw puzzle. How do you even know where to start? How do you know where do you start putting things together? And that's what George is alluding to. And which events belong to which processes or tasks, or is it repetitive, and so on. So just producing the graph there's a tremendous amount of machine learning and some data science that goes into it as well. And then we have data pipelines and so on.
Yeah, I'm sure.
And then once we do that, the next challenge is, how do you make sense of this? You put it all together. Does the human being understand what you have done? Because you have to combine things to the right level of abstraction. And there too, there are a whole host of challenges. So these are perhaps some that come to the top of my mind.
That's great. And I see Sheng Ding, for example, who I know Roland is saying, like, I've learned so much. I often wonder how I spend my days and what I can do better. I'm sure many of us are thinking that. Okay, let's take some of the questions coming in from the audience. And I think we can take the question from Parang Singh and Prasanna Kumar Reddy at the same time. They're both asking if you could give us a real business operation, a concrete example of where you've really seen a tangible benefit already coming from this interesting technology.
Yeah, absolutely. So, for example, one of our customers, a Fortune 500 life sciences company, has deployed this on over 1,000 users today globally. And what they're trying to do, and the value that they derive out of this, is threefold. One, they first just want to catalog how work is happening. That goes to the work recall gap. Hey, first, just give me the ground truth of what's going on. Second, help me figure out where is there unnecessary effort for my teams and what levers I should pull in what order to reduce. And so, there are actual sort of savings numbers of effort, because they want their teams to work on more higher value added work and so on. And third, using this data, help me find ways in which I can make my work go faster. These are three tangible business goals that our customers have been using our platform to solve, as an example.
Thanks. Let's go to James Damon, who asked two questions that are related. He asked, and this is reflecting on what you were talking about, again, Rohan, I think, about the work recall gap. He asked, is there a gap for team members understanding their own work? And also whether you looked at, or you do look at, team members' ability to recall each other's work and compare that to their manager. I think that's fascinating.
Excellent question, James. Happy to write an HPR article with you exploring this question. This is something we've been thinking about as well. In fact, the second question that you asked is in some sense the answer even to the first, which is what we have often seen is a team member can more likely account for their effort. But when George talked of variations, when you talk about variations across the team, it's very unlikely they will be able to account for variations across the whole team. And so therefore the gap will continue to exist when you look at it at a level of a team. At least that would be my hypothesis.
Yeah, fascinating. Okay, let's go to what I think a number of people will be thinking, and also gets to a decision that you've made in regard to this being aggregate analysis. So Jeff Hassan asked, in your experience, do employees view this type of data collection as threatening or intrusive? And kind of a related question I have to this when I was thinking about this is, presumably you have the ability to begin to pick up knowledge of gaps, like somehow collectively the teams are not, they're either hung in a step or maybe they're not working. So I just wanting to maybe tag that on to Jeff's question, because it's beginning to get at things that maybe the teams would begin to feel some tension around, even as a collective organization.
Right. So there are several things I'd like to say about this. The first of which is very early on when we started to solve this problem, we thought ahead and we said, look, if we wanted to run this ourselves, well, we wouldn't want anybody's names attached to any of this. We would want it to be anonymized. And so we said, okay, we're going to build this in its very constitutional DNA as the right ethical way of building technology here, which is, this is not about an individual. This is about a team. And our goal is not to we don't want you to identify individual X did well, because if you can do that, then you can also, the counter positive, you can say individual Y didn't do well. And that's why we've always aggregated this to a team level. Second is the piece of software that runs on everybody's machines. We never allow for this to run without the end user's knowledge. It's always opt-in. In fact, we have turned down, we're a young growing company, but we have turned down business where customers have said, you tell me who does X or Y, or I don't want to opt in. Then we say no, then we don't want to participate. And the reason we do that is also because, when Scout is running, users can interact with it. They can actually see what it's doing as well. And the next thing that we've also done is we don't collect data flat from everything. The manager and the team get to actually say, here are a list of applications that we use for work, like SAP or Oracle or whatever else and so on. And it's only from those applications that data is collected, and that data is available for inspection by the company and so on, so they can see what is being collected or not. So by default, it collects no data until there's an approved list of what applications it collect data. These are more kind of tactical and technical things, and we've done a range of these things. But more generally, our whole approach here is we want to make it as hard as possible for companies to figure out who's doing what. Can we guarantee it'll be foolproof? I don't think anybody in technology can guarantee it'll be foolproof. But we have tried to make it very hard, because again, in everything that you've seen in the patterns or whatever else and so on, it all gets aggregated to a level of a team. And that's the approach that we have taken. And thus far, we've seemed to have had buy-in everywhere, because we are very upfront and proactive and transparent about this. We bring this up as a topic before anybody else can even ask us, typically. And often in many cases, right, the champions for this technology have been the end users themselves, because in some sense, what we're doing is we're putting data and numbers to the pain. And this is something I think people often underestimate, the pain that end users go through when they have to do their work, navigating a weird, complex IT landscape. And there's no numbers for it, and there's no data for it. Right? It becomes an anecdote. Oh, I keep complaining to my manager, but my manager says, okay, but I don't know what to do. But at least now you can put some numbers to it, right? So there are cases where that's...
And that gets also back to the comment we had earlier from James, that some of the value here is this lateral exchange of information. So one thing that I just wanted to quickly follow up on there, Rohan and George, you talked about this idea that if you see a successful variation, You suggested you might want to template it or maybe standardize it, but I'm assuming that you don't see it in enough detail to really understand it yourself. So can you connect those dots? Do you go back to the client you're working with and say, hey, there's something interesting here, maybe you want to try to find out what's going on? Is that how you connect that dot?
George?
So this is really technology that the customers drive from the very beginning, because one, they have all the context themselves. If you go back to a little bit of what Rohan and I were describing as some of this technology is trained by the organization. So they're driving, here are the processes that I want to learn more about in the organization. They'll name them with exactly what they refer to that process as. And then they'll train the system based on the steps that they know they follow. Now, the really cool thing about what happens after that is, like we saw with the variations work, they might find all different kinds of variations come up from discovering the hidden patterns. But the key thing there that they have now is they have that relationship in the technology because they've labeled these processes that they've seen them. We've been building aggregations to pull these processes from existing systems that they have so that they can relate to it. Now, all of that information becomes available to them. They see the sequences, they see the variations, they see the paths, and then they're able to relate to the information that they see on the screen, which will say something like, the invoice process, was completed at this time, and they're able to basically relate to that. So it's all about the context that they have, and we're building it in a way that they can go, start to finish to gain these insights. And the technology even shows them, here's what's automatable, and tells them, here's why I think it's automatable as an example. It's literally built into there for them.
I see. Okay, thanks. We have just a few minutes left. Maybe I'll take the prerogative to ask the following. You have this notion of a work graph, and we think about the web graph, and we think about the social network graph. When we think about the web graph, we know there are centrality style algorithms that are useful there. When we think about a social network, we often think about recommending a friend. So I'm just wondering, if we think about your graph, do you see opportunities for things like centrality computations? Is there an interesting analog to what it would mean to recommend a friend? I guess your vertices are actions. So the friend of an action is an action that works with it. I'm not quite sure. Would love to hear your thoughts on this.
So David, this is something that we have just set up a research lab as a company, and this is something we are in the throes of studying, that is characterizing this graph. Like I'm imagining you're thinking of like Kleinberg, Barabasi, and so on,
right?
Web graph, right?
Yeah, all of our friends.
We want to do a Barabasi or a Kleinberg on this kind of data. But the way to semantically think of this kind of a graph and I think that's in some sense where the innovation of what we have done has happened, which is, if I do a step, right, what is the most likely next step? Or if there are 5 next steps, what is the likelihood of each one of these steps? I think that's perhaps at a per node basis, that's kind of the semantic of how you think of this graph. We don't yet have a characterization. I'm hoping the next 6 months we will. And I'd love to write a paper for one of the ACM conferences on that. So characterizing this graph.
Fantastic. Yeah, there's so much of interest here, and you can see, and apologies to all the other people who have been asking questions. You can see the talk has generated a lot of interest from the audience. Rohan, George, let me close out by thanking you again for a very interesting look at not only what you're doing, but also some of the things that you're finding, which I think is definitely interesting for our audience. Let me also maybe mention that there was a pointer from Annie Kuma to this notion of Taylorism in the questions. I confess I had to look up what that means, but it's a factory management system developed in the late 19th century to increase efficiency by evaluating steps in a manufacturing process. So it's kind of an interesting analog there. And I'm sure others in the audience were also thinking about causality questions I didn't get the chance to ask you about. But when we're thinking about the work team overlap and, is there a causal relationship when we think about context switching? You have very interesting data analytic, data science questions there that you can dig into.
That's right. That's right.
And I'm sure you.
If I may just say something about Taylorism.
Yeah, go for it, please.
I remember writing a paper about it in my undergrad years in history of science. This is not about Taylorism because it's not about industrialization or any of these kinds of things, right? Actually, in some sense, if we step back, all that we are saying is this is in some sense a product manager's view of how work happens. So if I'm a product manager, what I would do is I would actually go see how do people use my software, what do they find easy or difficult, and so on. And this is something that largely we find in a digital workplace is ignored. There is no easy way of trying to understand this. And this is, and the reason I point this out is such a perspective pivots the question from this is not just to help managers, but how can this also help users? And that is important too. And that's something that we're working on as well. Right? If for example, that's why George had in the future directions. If I'm a user, can this data help me find better mentorship? Because companies don't have ongoing mentorship. If I have frustrations at work, am I the only one, or maybe there are other people expressing similar frustrations, by the way, which we actually see in the graph. And that is not about Taylorism. That is all about, in some sense, we are trying to find ways to taking employees, managers, and everybody along, because everybody in some sense are trying to achieve the same thing.
That makes sense to me. So you're getting at empowering now the individual contributor to a team, and I'm seeing this even in the micro level within Harvard School of Engineering, where we've been working remotely now for getting on for 2 years, and it's harder to do that knowledge transfer. That here's the best way to do this, and I feel like this notion of a work graph, we can discover these things and exchange that information. So thank you again. This is fascinating. Delighted that Harvard's Data Science Initiative has been able to host you. And just in closing, so again, thank you, Rohan and George. And just in closing, wanted to mention to this audience that our next industry seminar will be with DraftKings Director of Data Science Engineering, who will be speaking on, this is Bradley Fay, and he'll be speaking on Thursday, March the 10th at 1:30 p.m. With that, we're over and out. Hope you all have a great day. Thanks.
Great. Thank you, David. Thank you very much for inviting us. Thank you.
Bye-bye. Thanks again. Bye.